Hello everyone. In this video we are going to set up vector search on Redis, and we are going to do this using Docker. This video is going to be little bit involved. When I say involved, there would be a lot of things which are going to be assumed that you already know. For example, concepts about Docker and maybe even Redis, because I won't be explaining much about Redis in this video. So I hope you get this agenda. So we want to set up Docker locally, not Docker, but Redis locally first, and then we want to um, uh, set up the vector search indexes. Okay, I hope it makes sense. So let's create a plan here of how we are going to be progressing in this video. So I will open a Visual Studio Code and I'll open a folder. Okay, let's maybe in the documents create a folder for Redis demo. Let's open it. Okay, so we have the Redis demo ready. Let me also open terminal within the Visual Studio Code only. Okay, cool. After we are done with this folder, let's create a plan.txt, because this is going to help us guide in our way to basically guide through these steps. Okay, what will be the step-by-step process of this video? First, we are going to pull the Redis stack image from the Docker registry. Okay. Secondly, we are going to run the image in a container and expose two ports. Now, when we pull Redis stack, it not only pulls Redis but also pulls Redis. So Redis is the default, and a CLI and a UI. It's called, I guess, Insights UI, I guess, if I am not wrong. Okay, and it is exposed at 8001 port. Now we pull the Redis stack and it will pull all these subcomponents as part of this image. Next, we are going to run this image in a container and expose two ports. What ports we are going to expose? First one is where Redis server is going to run. So this is where Redis server is going to run. Another one is going to be 8001 where Redis UI is going to run. Although you might not require UI in your production systems when you are using Redis, because UI is just to see the keys and documents that we create within the Redis infrastructure. So after we create this image and after we basically run this image, next we'll explore the UI, and then we will install a client. Now there are many different ways to interact with this server running on this port. We can run it via this Redis CLI, or we can, if you are comfortable with Python and not comfortable with Redis CLI, you can go for Python's SDK. I prefer Python SDK because I find it difficult to work with the CLI. Now, what we will do is we will install Python SDK for Redis. Then, after installing, we will connect with server that is running on the port 6379. We'll create some keys to kind of demonstrate whether it is working or not. Then we will create a vector search index. or maybe before this step, I think we should define a problem statement. Okay, define a problem statement that can be potentially solved with a vector search functionality. Then we'll create some dummy data, plus create a vector index. Okay, after creating the vector index, we will load the dummy data. And when I say load, essentially we will be creating some key value pairs in the in the Redis. Okay, finally we will use our index for query. Okay, so these 10 steps will complete our video. Okay, so this is the plan. Let's get started by this process one by one. Pull the image. Since I am on Mac, I need to start the Docker daemon before I can actually uh, one second, is Docker started? Docker, before I can actually pull images from, I think, yeah. So yes, so this is the dashboard. I don't have any image with the name of Redis stack. So what I'll do is I'll do Docker pull Redis stack. Now this might take some time. I'll just pause this video and I'll come back the moment it is done. So I'm going to pull. So it will ask me to allow, and then it will start pulling. Yeah, so it is pulling. Let's wait for a couple of seconds and I'll be back in a moment. Okay. Okay, the pull has been completed. Before I actually run this image in a container, I would like to open Chrome and I would like to open localhost at 8001. You see, currently this site can't be reached. Why? Because I have not actually ran the command for actually running this image. Let's clear this logs and let's now run the Docker image in a container. Now, after the Docker run, we can pass options such as we can specify port. uh, we need to expose 2 ports in the host machine. So there is this concept of Docker containers port, and we need to map that back to the host, because host is my laptop and Docker container is the it has its own porting system. So I want to map it back to the host. So I will map it like this, 6379. Okay, I will map one more port for 8001. Okay, after specifying these ports, I can also specify the name of my running container, not the image. Image is named as this Redis stack, but I want to name the running Redis container. So I'll simply say Redis stack. And after passing these options, after the run command, I can specify the name of the image. Okay, so Redis stack. Since I get this option, so I'll just hit tab. If I hit enter, what will happen? Let's see what happens. Okay, so you see it it has started running that here only, but I don't like it. Meanwhile, what I can do is I can refresh it and I can see my server is spinning up, but I don't want that first. So what I'll do is I'll just uh, force I'll just force it, and let's see this again. Now our server is not running, the UI server, and I would like to run it in detached mode. Detached mode means I don't want to see the logs. I just want to just run it in the background. So if I hit enter, it says The container Redis stack is already in use. Oh, I see. Because I named it already, I would like to first of all, I will have to first of all delete the earlier one. Yeah, the earlier one that I created. So if I can navigate to the containers here also, you see this Redis stack, it's stopped. Since this name is already taken, I have multiple options. Either I can just take this Redis stack container, so I can look at all the containers by running this command. So I can delete it by doing something like docker remove. But first I need to get the ID. So docker ps a. So I can get this ID, and I don't need to specify the whole ID. I can just specify the first letter, given that it corresponds to a unique container name. So I can say something like docker rm b. If I say this, I just remove that container. Now if I go inside here, I don't have that container anymore. Now I can run that command again. Yeah, so docker run detached mode. If I hit enter, now my container is running. You see this? Again it is running. And again if I go inside the UI, uh, I'm able to see this UI. So we are done with these two steps. Okay, we have pulled the Redis stack image, and we also have successfully executed, or rather I should say successfully ran the image inside the container. Now we can probably spend some 2-3 minutes in understanding different things that we can do inside the UI. If I go here, I need to accept these terms and conditions, and if I hit submit, you will get this kind of interface. Okay, now from here also you can create some keys. So if I click on this key, I need to specify the key type, and I'm assuming that you are already familiar with different type of keys. Let's have a simple string based key. Okay, we can also specify TTL, time to live, means which essentially means expiration. Let me add a name key as Rahul. If I hit add, I get this result here. Okay, I want to demonstrate one important point, because that would be used when we are going to build the vector search index. Let me create one string key called item in this format, item colon 1. Okay, let me just name it as 1. Add key. Let me create one more key, but this time I'll say item colon 2, and this time 2. Okay, you see naming convention that I have followed. Inside here, if I come here inside here, you see this is a list view. List view will list down all the keys that are there in your Redis cluster, and this is a tree view. Inside tree view, you see this item which can be expandable. If I expand this, so it has basically grouped. So after colon, we get this 1 and 2. So we have got these two groupings. Now why it is important for vector search? Because when we create a vector search index, we create it on this collection. Okay, this item collection, and then all the entries inside it will be indexed according to the rules that we are going to specify, that we will be seeing in a moment. Okay, so I think that would be it. You can explore more about the the UI on your own, but I would like to move on to the next point, that is install Python SDK. So I'll come here in the Redis demo, and I'll create a virtual environment here. So I'll say Python 3. I will use the default venv that comes pre-built with the Python installation, and I'll create a .venv virtual environment. So it's created. Now let me activate it. Venv source, oh not sorry, bin activate. Okay, sorry. Okay, so now my virtual environment has been activated. So I'll pip install. There is this package which we are calling as SDK called Redis. So if I hit enter, it will be installed, right? Okay, so let's now try to connect to the Redis server. Okay, so let's now create a Python file called connect.py. Now from here I would like to import a class called Redis class, because usually uh, that's how Python uh, that's how other client libraries, other SDK libraries are implemented. So you have this uh, so from Redis you have this object called Redis, and I can connect to this Redis by specifying my host and by specifying my port. And there will be one more parameter which is called going to be decode responses, because by default the responses that Redis is going to send will be in binary format, and I would like to see a human readable representation here. So inside the host I can pass the actual host that my Redis cluster is deployed on, or I can pass localhost if your Redis cluster or Redis instance is running on your own machine. And in the port I can pass 6379. Okay, now let's try to get some data. Okay, so what do we want to get? Let's get this name. Okay, let's see what do we get. Okay, so let's run this, because this would mean that my connection was successful if I am able to. One second. Okay, Python connect.py. So you see this Rahul. Why? Because I set the Rahul key, Rahul value here, right? Okay, I can modify it from here as well, or I can use Python SDK. Okay, so now we are done with connection part. We have connected with the Redis server. Now let's create some keys. We already did it using the UI, but we can do it using a client also. Now one type of data that we often want to set on Redis is Python dictionaries, or in other words JSON documents. For that specifically we have something known as hset. Hset means hash set. And don't, if you have never heard about hash, but you should have heard, because I assume that you are familiar with Redis, but hash is just a fancy name of dictionaries, Python dictionaries. In fact, Python dictionaries are also built on top of the concept of hash. Hash is an algorithm. It's a really beautiful concept. You should read it if you get some time. The first argument will be the name of the hash that you want to set. So I can maybe, let me first of all delete, because I don't want to clutter this. So let me delete these really quickly. All the keys I would like to delete. Okay, yeah. So now let me come to the list view. Okay, so I would like to set one hash. Maybe I would name this hash as product. Okay, and here there are many different ways by which you can set. So hash is essentially a dictionary. It means pro define a dictionary named product. So there will be a product dictionary here, but what will be the values, like key value pair within that dictionary, that we can define as in a mapping format. So I can have a product ID by something, maybe something like 123, product description, maybe shampoo. Okay, I couldn't think of a better name. Or price, maybe also, maybe $29. Okay, now let me copy this a bunch of times, and this time what will happen, what do you think will happen here? Let's see it. Okay, but to look at what happens, let me change this IDs. Okay, all right. Now if I run this connect again, nothing happened, right? Let's refresh it. Okay, so we have got one hash, one key called hash. The hash name is product. Now if I hit enter, you see all these mappings here. ID 1237. Oh, 1237. But what happened to these? Because what happened is Python first executed this, then it saw that the Python program wants to override the existing key. The key was product, right? So how can we possibly solve this issue? We can solve this by the trick that I told you about, specifying the colon. After colon, I can pass first product, second product, third product, fourth product. Now nothing, see, this is not nothing fancy, it is just defining new hash by the name product colon 2. But the one second, let me run it first. Yeah, so if I refresh it, you have got 4 hashes, right? Nothing fancy. You can see now these values appearing here. But if you go inside the list tree view, inside tree view we have got this product. Product is the top level header, and inside product we have got first product, second product, third product, and fourth product. This becomes quite convenient when, let's say, we have to do some vector searching on it. Let me delete these now because I don't need this particular keys at this point, because I want to simulate real use case. That's why I want to create a real data. Let me comment it out. Let's go back to the plan. So we we created some keys. Now I have to define a problem statement. You might be already aware that vector search are used for semantic searches. Normal text search or normal keyword search have their own strengths and weaknesses. And again, semantic search have its own merits and demerits. It shines when your user wants to search over your corpus in a semantically manner. They can type anything and they would like to get similar documents or similar results. Now here what we might want to do is, let's say you are a e-commerce company, you have a lot of product data in your Redis cluster. Now you would like to utilize it somehow. Maybe one way you can utilize it by recommending similar products. Okay, so you already for a given user, you already have in your Redis cluster for that user some products data, right? Now what if you could utilize that to recommend related products? So you might have a products tree inside this, and that products tree might have hundreds of products. You can create a vector index on top of it, and what it could do is it could recommend similar products, okay, based on some category, based on some embedding. Okay, there are a lot of steps involved, but I don't want to go into like how embeddings would be produced, how would we call OpenAI's API or maybe some other open source model, right? So let's just try to set up the vector search using Redis. Okay, so how can we do that? First, we have to get some dummy data. Let me go to maybe Gemini, and let me ask Gemini to give me some dummy product data. Generate 5 dummy product data with 3 to 4 keys in Python dictionary format. Give me the final maybe list of products. Each product should also have one embedding key with some random data for now, or maybe not random, maybe uh, with embedding key with some data. Okay, and dimension, let's keep dimension to 10 for now. Okay, let's generate these 5 dummy products data. Okay, so we have got these 5 products data. Let's copy it here, and let's maybe create a new file called ingest. See, although I'm trying to ingest this data using Python, but in your organization you might already be using Redis for serving low latency data to your customers. You would be using that data for creating this feature, right? Okay, so let me copy this connect command here. Okay, now one thing that I want to highlight here is that you can push all these things to the this Redis, but you won't be able to push this. So Redis essentially expects that you send everything in a binary format. Let me get rid of this price because I don't need price for now, because I want to keep it really simple. So all these fields should be in a binary format, and by default Redis Python SDK will take care of everything except for the embedding field. Now, how can you make sure that embeddings are sent in a binary format? For that, you will have to maybe write a custom helper function, which will basically take your products and convert it into a it into a binary format. Okay, so let me maybe minimize these products data, and let's come here. Maybe I will loop through it. Okay, so I'll say for product in products. Okay, now I would like to get the ID of my product. Okay, why do I need that? You will get to know why. Product dot get. Now what is the name of the ID field? Product ID. I'll copy it and I'll paste it here. Now if you recall in the connect, when I was showing this client dot set, I will copy it and I'll paste it here in the loop. Now within this what I want to do is I want to basically get rid of this dictionary here, and I want to uh, specify this product that I have, but I can't specify since it has an embedding in a form of list of floats. I can't specify it directly. So what are my options here? So first of all let's take care of this 4 here. So I did product plus, I want to string convert it into a string, and I want to pass the ID here. So ID will differentiate the products, and in place of mapping I want to pass product, right? But in product I want to change the embedding. How will I change it? Maybe I have some function, helper function called toBinary, which will take this old embeddings and it will convert it into a binary format. Okay, let's define this toBinary. This toBinary will take a vector and it will return a binary format. How will it return? So for now I will just use a inbuilt package. Let me import a package called struct. Okay, so this struct has a function called struct.pack. Struct.pack, it takes two arguments. It takes the format in which you want to convert into bytes, and it takes the actual vector. So vector I'll just spread it using star operator. In the format what I'll do is I need to specify format of the vectors, right? So what kind of vector I'm dealing with? So I will start this with this symbol. That's how struct work, and I'll append this f. So how many f's floats I have? I have number of floats equal to, one second, sorry for that. So I will len of vector, so whatever entry, so I have got 10 vectors, so it will return 10 f's here, 10 floats, and then I will toBinary will return that, and here I am using that as the, okay, what happened here? Let me exit out of it. Let me exit. Okay, so now after this I can also print it, because by printing it what it will do is it will print the number of keys that were appended. What is happening here? I don't know why. Okay, I see. ID, let's try running it. Python ingest.py. What's happening? Unexpected indent. Okay, what's happening here? Okay, I see. Oh my god. Okay, Okay, so now it should work, and let's see how does it look like. Okay, so you see 444. What does that mean? That means for each product, four keys have been added to this hash. If I reload the here, and if I go inside the tree view, I have got product, and inside product we have got product 1, product 2, product 3. Each product has got this these key value pair. So now our data has been set. Now we are good to go with the creation of the indexes. So how can we create the vector search indexes? See, it's an involved process, and it's specifically involved for those who have never done it before. If you are getting started with vector indexing or embeddings for the first time, it might overwhelm you, but you have to bear with me because the end results are going to be really good. Okay, so let's create a script called create index. Okay, now when we create an index, as I mentioned, we will be creating an index on this product, right? So we need to first of all define some parameters. Let me do one thing. Let me copy this code here, and now let me create a parameter called index name. I will have to define an index name. Maybe I will call it product index. Okay, now I need to specify the index prefix. Okay, what will be the index prefix? What do you think? I want to index all the products that starts with products colon, right? Product colon. Okay, so this is my index prefix, because your production Redis cluster might have millions of key value pairs, but you want to create only those index on top of only those keys that starts with product colon. That might have, let's say, 1000 or 10,000 products data. Okay, so what we do is we call a function called client.ft. ft means full text. Okay, now it basically exposes various methods of basically provided by full text functionality, full text search functionality by Redis. Inside it, I can pass my index name. Since currently no index has been created, I can call on it only one method, and that is create index. Okay, inside the create index, you need to pass two things. First is fields, second is definition. Okay, let me so I'm just adding placeholder. So I'm going from top to bottom. So I'm creating this skeleton first, and then I'll explain what are these fields and what are these definitions. Okay, so now to define these fields, let's say I have this fields list. One second, let me copy this, and let me create a definition also. Let me copy this as well. Okay, so now where will these two come from? Okay, and also I will wrap this up in try block, try and except block. So if let's say this succeeds, it will mean that our index has been created, which means we can print this statement: index is created. If let's say it fails, there could be two kind of error. There could be error in the way we have specified this vector search, or we can have a duplicate index name. So maybe this index has is already created. Okay, so in that case we will print the error. Some error occurred. Mm, or maybe I can say index already exists, or some other error. Okay, so I'll print the error here. Okay, so let's define the fields first. So fields will be a tuple. It will be a tuple on which I want to create an index. Definition will be again a definition will be a type. So I need to import some classes here. So I will import, so from redis dot commands dot search dot field. Inside it, there are two type of field I want to get. I want to get a text field. I want to get a vector field. Okay, again from redis commands dot search dot definition, index definition, I will import two things, two classes: index definition and index types. I hope this is making sense, because I know this is quite overwhelming because we are importing a lot of classes here. So let's define the fields first. Inside the text field, I will specify the name of the text field that I want to index on. In the ingest, I created it on name, category and embedding. Let's index name. Okay, so that so when I'm doing the actual querying of the index, I can also specify name besides the embedding. So name, and then I can pass vector field, or maybe category I should index. It is better contender. Okay, so category, right? So in the vector field, again vector field has got name. So what is the vector field name? It would be embedding, right? Then what kind of algorithm we are going to follow? Usually in production we follow HNSW, but you are free to use flat or maybe some other algorithm. Okay, now inside it I will pass one more dictionary which will specify the options for this uh, HNSW algorithm. So what kind of options we need to pass? We need to pass things like distance metric. So the metric which is going to be called to compute distance between two see, algorithm can be flat, HNSW or SW. Flat means it it won't be using any algorithm, it will just be computing cosine similarity between all the pairs of vectors. Then there will be dimension, and dimension for dimension I will pass 10. I guess we had 10 entries, right? 5, yeah, 10 entries. And then there would be one more thing, and that is, I don't recall what I think that would be it. So these two parameters are going to define your vector field name, type of algorithm, and then algorithm specific settings: distance metric, dimensions, and this. Now in the definition, I will call this class called index definition. Inside it, I want to specify what kind of prefix I will be using, and here I specified the prefix as index prefix. Okay, after prefix I need to specify one more parameter, and that is index type. What kind of index type we have? We imported this index type, and it has got one called hash. Now hash, the reason I'm using hash, because hash is the so we are dealing with hash type of key value pair. Okay, so that is why I, so now our try and except block is ready, right? So just to summarize, to create a vector search index, we need to pass fields, we need to pass definition, and we need to pass and in the definition we need to pass what kind of index we are dealing with. We need to pass index prefix, and we need to pass type of index. So it will look at your Redis cluster, and it will only index those which starts with index prefix, and which has a type of hash. And then in the fields we are specifying what are the fields that we want to index on. First is embedding, and then another one is category. Okay, so let's now, maybe I think I'm doubtful on this, maybe let's search it on Google. Okay, vector field Redis HNSW, or maybe I should add also Python. Okay, let's see. Okay, so type, I think type is also I need to pass. Dimension is good, distance metric is good, and type. And in the type I can pass float 32. Okay, so this defines our indexes, and let's run this script now. Python create index. So you see index is created, but if I run this script again, you see what happens. Index already exists, right? So I hope you understand this point now. Now the final step is to basically query it. Okay, query this index. Query.py. Inside query.py, what I'll do is I'll copy these code blocks. Okay, and let me get rid of these struct I will use. I don't need index prefix, and in the index I will I want to take this vector as the query vector. Okay, query vector. Okay, so this is my query vector. So I will take query vector and I'll convert it into a binary format. And how can I convert it? I can maybe use the toBinary function that I defined here. Okay, toBinary, and inside here I will pass query vector. So now my vector is in the binary format that Redis accepts. Now what I'll do is I'll create a results object and I'll call client again ft full text. This time I again will pass the index name, but now I can call search method on it, and inside search I need to pass two things. First one is query. Okay, query and query parameters. So query parameters will take vector, although you can call this vec anything that you like, and inside it you can pass the vector binary. What will be this query? Now this is where the power of Redis search comes to. This query is essentially a string. Okay, so let me define the query here. Here you can potentially create a hybrid search kind of system. So it has two parts. It has part on the left, it has part on the right. Okay, so part on the left right now I am saying get me all the key value pairs defined by this index, which means this index has got how many entries? Some 5 entries. Get me all of those. Star means that. And on that, what you do is you run a KNN algorithm. KNN algorithm. Okay, and here in this KNN algorithm, you run it on embeddings. Embedding, sorry, key embedding will be there, and what will be the input? It will be vector. Okay, and this knn, how many basically how many vectors I would like to return? Maybe two for now. Okay, so 2 knn. Maybe let me also see if I am using this right. Okay, query in Redis. Let's see. So pre-filter, so this is called pre-filter, the first part of the query. And here we can also specify category, like for example I want to get only electronics. KNN2. Oh, I see. I think I should have added. Yeah, got it. So that's what I was not sure of. So KNN2, and then at the rate embedding the field, the vector field in the index schema, vector, a placeholder. So vector will be a placeholder. Now what we can do is in place of query I can pass this query, and here I can loop through this document. So for doc in result dot docs I can print the doc dot let's say doc dot. So for now let's print doc here, and let's see what kind of results we get. So query. Okay, so we are getting a lot of documents, right? So how many document did we get? Let's see. We get first document, second document. So we got two documents, right? First document. So and we are also getting the embedding score, right? So this document had, and let's see which embedding we copied. Let me see. I copied the wireless noise cancellation. So this particular document is having uh, so this particular document is having this score. And then the next similar document, let's do one thing. Let's get all the document and let's look at the score of that. Maybe knn 5. Okay, and I'll print the document again. Okay, so now, so embedding score 1 1, which means organic cotton yoga mat. Okay, so the reason it is not making sense is because these embeddings are nothing, they are just rubbish, and they were generated by these are random, right? But the idea was to basically set this up using Python, right? So I think at this point I would like to stop. Maybe I could also cover how you can expand this star into hybrid search kind of thing, by including, let's say, first only, let's say you have got 10,000 documents, no, not document, 10,000 hashes. You might want to filter it down to electronics first, and then inside electronics you might want to go for further searches, similarity searches. So I hope it makes sense, right? Okay, so thank you so much for watching this video. Let me know how I can improve this one, and maybe something else that I can cover. Please do let me know in the comments. Thank you so much.